Hello students, welcome back to the series of lectures of Intermediate 1B. While we were dealing with this video lessons, since so many previous video lessons, that is from the differentiation as well as the trigonometric ratios up to transformations. So here in the differentiation part, we are coming across the transformations of and also the trigonometric ratios. So those who have not watched that chapter, in the playlist go and check. There are 40 video lessons of trigonometric ratios up to transformations. We are involving with the trigonometric ratios throughout the differentiation part. Now let us quickly start the exercise 9C here today. Those who have not watched the previous exercise of 9B, just click on the iCard, you will be notified, and the links of the differentiation chapter from the introductory part till 9B exercise you will find in the description below. Okay, let's quickly dive into the problems of 9C exercise. First bit I have written down. Find the derivatives of the following. I have written two problems here. Sine inverse of 3x minus 4x cube. We see clearly there is some relation here, 3x minus 4x cube. This is in the form of some trigonometric ratios. So that's why I have told you, just go to the trigonometric ratios up to transformations chapter in the playlist. So you will find out all the formulas. You get them perfect so that you can solve this 9C exercise. If you see, it is in the form of 3 sine theta minus 4 sine cube theta. That is nothing but sine 3 theta. So, what we will suppose? This we will suppose as some theta. Okay. So, put or let, just put theta equals to 3x minus, put sine theta. Let us suppose, theta is equal to, we will put here x is equal to sine theta. Okay, put x is equal to sine theta. We will do it that. But x equals to sine theta. Okay. So if we do that, this becomes 3 sine theta minus 4 sine cube theta. That is nothing but sine 3 theta, isn't it? So let us suppose this. So why we are supposing this? We know the formula of the trigonometric ratios of this. So if we keep that, it becomes sine inverse of here 3 sine theta minus 4 sine cube theta. So this becomes sine inverse of sine 3 theta. So formula of sine 3 theta we know. Here let us suppose this function as our y. Okay. So we have to find the derivative. So we should find the derivative of dy by dx. Okay. So this is y. So dy by dx. So derivative with respect to x. Here sine inverse and sine goes off and we get 3 theta d by dx of 3 theta. Okay. Here when you are supposing x as sine theta, so theta will become sine inverse x, isn't it? Yes. Shifting to the other side. So that we will substitute d by dx of 3 sine inverse of x. So that constant comes out and derivative of sine inverse x is equal to 1 upon under root 1 minus x square. So this is 3 by under root 1 minus x square. Yes. Here we have supposed sine as x as sine theta. 1 minus sine square theta comes to cos theta again. This also we can shift it here is equal to 3 by root of 1 minus, or else keep the function as it is. We can also shift it into the form of, because x is equal to sine theta, sine square theta is again cos square, under root comes to cos, this becomes 3 secant theta. But no need, you can, because here asked only the derivative, you can stop it till here. The second problem in this, the same way, but I want you to do it for practice. It is cos inverse of, here we have 4x cube minus 3x. So simply the same way, here sine 3 theta, here cos 4 theta, where x we have to keep it as cos theta. Do it for yourself. Let us move on to the third problem here. Here by seeing this, we have to assume x. Okay, so here we have put, so this is in the form of 2 tan theta 1 plus tan square theta, so that becomes sin 2 theta, right? So let us put here x is equal to tan theta. So if we are perfect in the trigonometric ratios formulas, then only we can apply it. Okay, so keeping it, so like I am supposing this as y, so we'll find dy by dx. So sine inverse of, substituting here 2 tan theta by 1 plus tan square theta. Okay, so when you are supposing x is equal to tan theta, so theta will automatically will be equal to tan inverse of x. Now this is nothing but sine inverse of, this is the formula of sine 2 theta. Sine 2 theta formulas, there are 3-4 formulas. In terms of tan, this is sine 2 theta. Okay, so this becomes just 2 theta. So we have to find the derivative. Dy by dx is d by dx of 2 theta. Theta here is again tan inverse of x. So this comes to 2. Get it out. So this is 1 plus 1 by x square simply. So 2 upon 1 plus x square here. Okay, pause it and note it down. So here moving on to the fourth one, tan inverse of a minus x by 1 plus ax. If you clearly see in the previous 3 problems we had only one x variable. Here we have also a. So we will suppose a as some other thing and x as some other thing. Here tan inverse of here. If you are seeing this, it is likely in the form of tan alpha minus tan beta by 1 plus tan alpha tan beta. Okay, that is nothing but tan alpha minus tan beta. So here we will suppose this as one function and this as other function. So we will put a as some tan alpha, okay, and x, this a as tan alpha and x as tan theta or beta, some other, anything you can assume. Okay, so here let us substitute, this is our y. So tan inverse of tan alpha minus tan theta divided by 1 plus tan alpha tan theta, right? This will be reduced like tan of alpha minus theta. So tan A minus tan B, in that formula it will be reduced. So this becomes tan inverse and tan goes off, it becomes just alpha minus theta. Here again alpha is equal to tan inverse of A and theta is equal to tan inverse of x, that also you can write. So y is equal to tan inverse of A minus, and theta is equal to tan inverse of x. Now we have to differentiate. We will be first simplifying it, then we will be differentiating. So dy by dx is equal to, here 1 upon because this a is some constant, isn't it? So the derivative of tan inverse something, this constant is 0 minus, for this derivative is 1 by 1 plus x square. So simply the answer is minus 1 by 1 plus x square. Right, this is a constant. So for this we have 0, derivative of a constant. Now moving on to the next one here. If you see this, first we will simplify this. Already it is not only in the function of x, it is having the trigonometric functions itself. So we will simplify this first. So taking that 1 minus cos x by 1 plus cos x. So that is here this becomes 2 sine square x by 2. Sine square x by 2. Again 2 cos square x by 2. Yes, right. Here we have also squares. Here squares and square root, and these will be cancelled. You get only sin x by 2 by cos x by 2. So that is tan x by 2. So tan inverse of tan x by 2 will be remained. This is our y function, right? So here we are not supposing it as theta because it is already in the form of trigonometric ratio. So let us simplify this. Okay, then we will derivate it. Okay, derivation of this tan inverse is just x by 2. We have to find d by dx. So that is simply half. 1 by 2 comes out, dx by dx is just 1. So the final derivative is this. Positive one, secant inverse of 1 by 2x square minus 1. Here this is secant and this is 1 upon this. So if I suppose x as cos theta, so putting x as cos theta, x is equal to cos theta. Okay, so this becomes, let us simplify first this part. Okay, let us write it, substituting here. Okay, 1 by 2 cos square theta minus 1. So, okay, so this is equal to secant inverse of 2 cos square theta minus 1 is cos 2 theta. Okay, cos 2 theta formula. So that is y equal to secant inverse secant of 2 theta. This one. Okay. So that is equal to, these two goes off, only 2 theta. But what is 2 theta? 2 theta. Theta is cos inverse x. 2 cos inverse x. So we will do the derivative. dy by dx is equal to 2. Cos inverse x derivative is minus 1 upon under root 1 minus x square. So this is minus 2 by under root 1 minus x square. So I have left over the 6th problem that is not involving inverse. Like the 8th problem, we have the 6th one. So I have left over for you to practice. Okay. So this is as the 6th problem only. Now here there is no inverse. Just we have to go as derivating in the chain rule only. So here let us do, we are supposing this as y. So deriving with respect to x to start. Here sine of something, so derivative of sine of something is cos, isn't it? Cos of, this is as it is, I have written, just applying the chain rule. So derivative of sine is cos, isn't it? And we have to apply chain rule for this. So let us write here tan inverse of e to the power of 2x, and we should find the derivative. Okay, here in the next step we will do cos of tan inverse of e to the power of 2x, derivative of tan inverse. Okay, tan inverse is 1 upon 1 plus x square, but here x is this, e to the power of minus 2x whole square. Again the chain rule, this is not x, so we have to do the derivative. So I'll write here just the, we have to find the derivative. In the next step, cos of tan inverse of e to the power of 2x, here multiplied by derivative of e function, e to the power of any function is just e to the power of minus 2x, but here there is no x, so we have to do again the derivative of 2x. Okay, so this function is 1 by e to the power of minus 2x whole square. So let us write, that is cos of tan inverse of e to the power of minus 2x. Here derivative of minus 2x is just minus 2. So here multiplied by minus 2 e to the power of minus 2x by 1 plus e to the power of minus 2x whole square. So you can write it 4x also, you can write it here. So this becomes in the simplified 2 e to the power of minus 2x cos of tan inverse of e to the power of minus 2x, right, divided by here 1 plus e to the power of minus 4x. Okay, this is the final derivative. So the same thing, since there is no inverse involved, So the same thing is there in the 6th problem. So that I have left over for you to practice. Just going on derivating using the chain rule. Hope you have understood today's 9C exercise. This section is over. With this we have completed. We will see the next section in our next class. Thank you all.